완성. Teacher. Prof is wrestling. First thing. What is your first? Tang. T-A-N-G. Just like the Tang Dynasty. Huh?
D-S-A-N-G.
D-E-T-S-T-H-A-N-G. Is it related to the Tang Dynasty of China? Li Xiaoming? Li Xiaoming?
It's Tang, D-A-N-G.
Yeah, in Korean we call it Tang. So Tang Dynasty, the initiator of Tang Dynasty is Li Xiaoming. Oh, I know that. Right. So your family name actually related to. So you're from China actually. Tang is the first name. Sam. Okay. Jinan. Michael, right? So you did the history.
I did CE actually.
Check your. I just want to see the make sure face and your name. The list. Okay, we are actually doing mass balance. As a rate, mass balance is very, very important when you want to solve the problem and also when you design chemical engineering system. This is very, very important. Right. We actually are done with the state mass balance. We solved some problems. Also, we are dealing with some more environmental related problems by adding more flows. So, and also, flow and fluxes are totally different because flux is sort of related to mechanical term. Flux is much more useful when you solve numerical problems. So don't forget this. Flow equals flux times area, and flux equals flow divided by area. I think we actually finished it here, right? So I'm not just in a remote area of the car, the concentration of pollution in outdoor air, like ground level, average micro of the this is kind of average area that is very small down. Sulfur. Well, actually, sulfur is the name of the race, actually, not the specific name of the carrier. They are race, sulfur, right? So the concentration of aluminum at the ground is around the 94 nanogram per cubic meter. As it said, the shelter's dwelling, inside the house is the concentration of aluminum is much more higher because they are burning the woods and for warming their house. At the same side, the aluminum concentration on top 1 centimeter of fresh snow averages 0.12 microgram per gram. All this shelter's house here, and the the troposphere concentration of aluminum is 94 nanogram. There is snow in actually here, and the concentration of top 1 centimeter of fresh snow is aluminum concentration is 0.12 microgram per liter. Let's say this is aluminum snow. And also 3-day snow at the same, top 1 centimeter is the aluminum concentration is from the let's say snow 3 days. Is 0.2 microgram per liter. Well, our assumption actually start the aluminum maybe comes from this is Nepal, so beautiful country of Nepal, and here maybe Korea, Japan, some still industry make aluminum and other heavy metals, and the particles can transport it to actually west. So it's just a train up to Nepal, Mount Everest, and it can reach some places near the Sherpa's house. Unfortunately, we can say unfortunately. So, what is the average deposition velocity? We just want to know the velocity of the deposition velocity of aluminum at this area from maybe. So assume the density of snow is 1/10 that of water. Well, actually, this question from the very famous street called have you heard about this? Have you heard about Silent Spring? Right? So maybe you guys mostly read it from the high school. Very famous book, which related to chlorinated organic chemicals, human carcinoma. Well, anyway, so because we are dealing with flow and flux and area, so we can actually think about some useful equations, right? And then we just put some initial and boundary conditions, and we can get the answer we want, right? As I already taught, understanding the question is very, very important, and simplifying the boundary is important, then applying is important, right? Well, I really don't know how to solve the mathematical problem well. Well, in my high school days, we usually solve the Japanese, mathematical text, and we actually, didn't check all of the solutions actually. Same solution, win. But I just exposed the solutions here because we don't have time to, get a chance to solve the problem here for you guys. Well, actually, that's step one. Well, because we get the flux is deposition velocity times concentration. And we can get flux from the atmosphere, then divided by atmospheric concentration. So we can get deposition velocity, right? This is very easy, isn't it? Well, flux is mass of aluminum is now divided by area and time. In the case, well, we have 3 different days. different concentration of aluminum concentration of the snow. So we can get the mass from aluminum from each different concentration change actually. And then we actually need to know the volume of snow. Well, volume is the area times the height or depth, right? And then we multiply density of snow. We can get the deposition velocity here. All right, the flux and the concentration difference times volume is stock. I mean the mass, and then divided by area and residence time. You know, the area could be very, very important, but fortunately, the area can be canceled out, you know, from each side, and we can have this simple equation. So we just put in the concentration difference here, and then multiplies the density of the snow. Why? Because this is just a gram per gram concentration, right? So we need to multiply the density so we can get the concentration of aluminum in volume, right? Then the area is not important. It can be canceled out each side. And we have the depth of 1 centimeter and the difference of 3 feet. So we can have 2.7 times 10 to the minus 3 microgram. Right. Then flux. We just divided by the concentration with 94 nanogram. The aluminum concentration of the troposphere in Sherpa's dwelling is 94 nanogram, right? Then we just multiply all the conversion factors, day, hour, second, and we can have 0.33 centimeter per second. This is very typical value. Think about this is aluminum deposition velocity, right? I think I have told you the episode of the PBDE in polar bear's blood and also human model milk. Compared to the PBDE, PBDE is organic chemical, organic chlorinated chemical, brominated chemical. Compared to that organic chemical, which one has higher deposition velocity when we compare to this heavy metal deposition velocity? And if you can decide why the deposition velocity is so important, what does higher deposition velocity give you? Higher deposition means higher concentration, higher contamination, right? So you can get some idea, you know, from the this higher, lower deposition velocity. So which one is higher? Is it proportional to the mass of molecule? What about the chemical property of the organic chemical and inorganic chemical? Is inorganic much more hydrophilic or hydrophobic? Think about that. Organic lead how do you read this? Not in Korean? No, in English. Well, I can give you spelling of PB is yeah. This is what KAIST sophomore student can read. Sam. What about Michael?
Do you want me to read it?
Huh?
Do lead.
Any other opinion? Yes. Well, READ is read. Well, this result can lead to very pathetic, results. In that case, we can read it as lead. But when this is related to contaminants, we will read as read. So never ever read this lead from this time. So just to show your knowledge too. So red is very significant problem when we are dealing with crude oil. Crude oil actually includes all the contaminants. Actually, it contains heavy metals. It contains high molecular weight of hydrocarbons. Their red always exist. Well, actually, red you can touch it because red cannot be easily dissolved on your hand because that is very hydrophilic. Philic, hydrophilic. Hydro. What is hydro? Which is related to water, right? So this is actually water, or aqua. This is also water. Philic. What is philic? Philic. Love. So water-loving compounds, right? What is antonym of the hydrophilic? Yeah, so we call it hydrophobic. So, which one is hydrophilic? I already said aluminum is hydrophilic. Is oil hydrophobic or philic? Why? Yeah, it cannot actually mix up each other, right? If you just put water into the diesel fuel or oil, you can see it's strengthened, right? So we call it hydrophobic. Red itself is very hydrophilic. So if your hand is contaminated with red in crude oil, no, I mean just in aqueous aqueous state, well, you can easily detach the red on the surface of your hand by washing it, right? The problem is, if the red is complexed with organic chemicals, let's say hydrocarbons, CNHN particles. This one is very hydrophobic, and it can be very easily absorbed on your skin, and it cannot be easily detached. One big problem is the chemical itself actually have very high, preference to near the human actually flesh. So it can penetrate your hand, and this organic red complex actually enter into your body skin system. So if you just put it in there, and the organic red can penetrate your hand, and the organic red itself actually concentrated in your body, cause carcinoma. So every environment, everything can cause you carcinoma, cancer, right? So anyway, my purpose is, so far we just compare four things with respect to physical properties. But the important thing is, environmental chemical properties and their structures are very, very important for human health and related effects. All right. And the next problem is radon problem. Well, as I already talked, radon, which is kind of one of the radioactive chemical, in my, not high school, well, maybe around the elementary school days, most of the spa in Korea, they just put the advertisement. Our, bathtub actually include high concentration of radon, because the stupid, the owner of the bathtub actually think such kind of mineral can give some kind of health promoting effect. Well, as I already taught, you guys can see the contents of the chemicals actually, cations and anions in drinking water. As I already taught, well, I think the concentration itself on the label is very good for your health. The problem is if you increase by 100 times, well, actually, you are in another world. Well, anyway, I really don't know. Radon can give any kind of health promoting effect. Based on the EPA's, evaluation, this can cause also the same, carcinoma on human body, actually, especially lung cancer. I have some cartoon here. Well, I really don't know. This is usual house in the United States. So they have kind of, underground, storage. There are many types of the radioactive contaminant sources here, and they can penetrate the ground and also penetrate the concrete structure. Then you can contaminate the air of the environment, actually. Right? So, wow. You guys can ask me, Professor, is there any place we can stay in, peace and, healthful, environment? Is there? Think about that. You guys may be very, careful on the microorganism. If this guy affected by the flu, maybe tongue at next place, maybe don't want to stay with him actually, right? Why? Because he actually care about the contamination of his body by microorganism, which is higher molecular weighted chemical. Active. But you guys, in your mind, in your thought, you really miss one very significant fact. Microorganism is also chemical, active chemical. But think about that. In this environment, radon actually, threat you, and in this environment, the hydroxyl ozone, nitrate can, threat you. Think about that. If the concentration a little bit increased, that environment can kill you faster than the microorganism. Maybe Ebola virus, HIV, well, they can give you maybe a month, or maybe HIV infection in old days, or they can get killed in a year. But nowadays, it is just like the hepatitis. If you have, take the good drug, well, you can alive, actually, be alive, just like the ordinary people. But if you are exposed to radon or 10 times higher concentration of this cation and anion, you can get killed in a second. Wow. So you guys are really, really exposed, very, dangerous environment. One thing that I want to give you, I think the female student here really like the spa and essence oil masseuse, right? Well, it is very expensive, so you guys cannot have. Maybe your parents can offer you, but not right now, right? Maybe the price is around the $100 per hour, maybe. But the important thing is, I cannot ask you, have you ever been there? But anyway, I never ever been there before. Well, anyway, I just read the paper on Saturday. Well, essential oil, that is very, good perfumed oil. It can, make you very peaceful state actually. But it includes a bunch of biogenic volatile hydrocarbon. Have you heard about the delta limonene? Limonene. Well, if you just extract the lemon peel, well, you guys can maybe when you are young girls and boys, maybe you just take some tangerine peel and then put it to your sister and brother, right? So the rickets actually go forward to their eyes, and the smell is very good, though, right? But anyway, the main source of that good smelly chemical is limonene. And in the essential oil, limonene and pinene. Have you heard about the pinene? Where it comes from? Yeah, pine tree. The smell of pine tree, and this is pinene. So most of these essence oil usually spa includes high concentration of limonene and pinene. The important thing is those chemicals actually include this double bond, which is very reactive to hydroxyl in the air, which is around the 0.9 ppb level. On ozone, maybe the similar concentration. So these two can react very well. It is just like the ozone in the atmosphere reacts with the hydrocarbon from the exhausted vehicle gas. So think about that. Why the exhausted vehicle gas is so toxic? Instead, why the smell? The emitted gas from the essence oil is so good. Well, the smell is totally different. But the important thing is the exhausted vehicle gas also includes this double bond. So it can react with ozone and hydroxyl, and then finally it can cause organic acids. And then organic acids getting together, and it can make particles called aerosol. Well, we call it dust. Dust. And also, this is one reaction mechanism, and the other way, this can cause. What is this? HCHO. Aldehyde, formaldehyde. So this is very interesting. This is the bed, the female usually, have masseuse, essential oil. They're just right on the bed, and the therapist actually doing some masseuse using essential oil. And the environment around the spa, hydroxyl and ozone 0.9 ppm. This ozone and hydroxyl can react with this pinene and limonene and produce formaldehyde. So, what do you say? You think the essential oil actually can make you, impatient, and maybe those oils can, produce kind of increasing body, health, right? But in fact, your body is contaminated with formaldehyde, which is top, first carcinogen.
Wow.
Right? Yeah.
Question about the gas emitted from the vehicles.
Mhm.
Why do they? There's carbon double bond. I don't get why there's still reduced forms.
Reduced form of carbons
Yeah.
in vehicle gas. Well, the thymine and limonene compared to all the hydrocarbons from the vehicle is totally different. But the hydrocarbons actually, aliphatic, but sometimes it includes double bonds in their structure. So compared to single bond, double bond actually has higher affinity and activity for the oxidants. So I'm not saying, the reaction, the products from the reaction is totally the same. I'm just talking to you some kind of possible episode. So well, anyway, important thing is just don't breathe when you go to the spa, and also masseuse place when your mom actually put on $100 on it. But important thing is, well, it can cause you good hair and whiter skin. But important thing is you are breathing from aldehyde. One more thing. Well, in Korea, it is very silly, I think I already talked to you some of them here. This is one nice cup of coffee, right? Here, the major source of chemical is caffeine, right? What about the green tea or black tea? Green tea, you guys know, it also includes high concentration of caffeine at the same amount. Which one has higher concentration? This is not the answer of my question. Guess. Any guess? Coffee, green tea, black tea? No. Well, actually, green tea has 1.5 to 3 times higher concentration of caffeine. But the important thing is, the pregnant women in Korea hate to drink coffee because the caffeine can cause some, harm to their baby. Right? But important, one more interesting thing is they drink green tea. The concentration of caffeine is higher than the coffee. Why do they want to drink more green tea? They just don't want to, drink the coffee. Well, somebody can say, well, there are some more useful chemical compounds, catechin, and some more useful, chemicals there. But just focusing on the caffeine, the concentration of the green tea is 3 times higher. Is caffeine in green tea totally different to caffeine of coffee? Yeah, you guys never ever thought like that, right? So this is not stupid and silly fact actually. 불편한 진실. Okay. Well, if you know chemistry, environmental chemistry, environmental science well, you can live a little bit longer. I bet that. All right. So, well, anyway, the radon thing. Well, in my elementary school days, everybody think radon is very useful to human health. But nowadays, if you breathe the air contaminated by radon, your lung actually, bombarded by radon. All right. Well, I also think that depends on the concentration, but radon is not good. So radon gas enter an average building at a rate of 1 picojoule. This is very there is radon sources, all radon all took place here, and the radon actually, although this house actually have concrete structure, sheet settlement here, rate 1 picojoule, right? 1 picojoule per hour in second. And consider a house with a foundation area 200 square meter. So this place, the area here is 200 square meter. And indoor air volume, because this is radon gas, so the volume of the gas here is 1,000 cubic meter. Assume that the house is well designed for energy conservation. Well, this is very, very important. Energy and environment always go together. Well, nowadays, energy problem, we think this is very significant, right? So, most of the chemical engineers are focusing on the production of energy right now. So, environmental engineering is a little bit, at the, staying in the minor place. But 10 years ago, well, actually, nobody cares about the energy market. So most of the environmental projects, actually, professors and researchers, and even physicists and chemists, their research funding sources are the mostly environmental. So if you think this is time to start, your career as an energy scientist, I think it is a little bit late. But think about that, to start your career as environmental scientist. I think that's better. I'm not because I'm environmental professor. Right. So the energy conservation, the ventilation rate is low, and only 1/10 of the air in the house is exchanged. So 0.1. Portion exchanged, I think every hour. What will be the average steady-state concentration of radon-222 in this house? So we just want to know the concentration of radon-222. You don't need to know radioactive half-life of radon. So the half-life of radon is 3.8 days. This also can be splitter count. All right. One thing you should know about the air contamination. What is the best way to solve air contamination? What is, I cannot say you are superior to plants because you are animal. What is tactic, of the plants against their threats? Think about that. If the germs, maybe microorganisms, approaching to you or approaching to plants, you are animal and you are this is different. What's different tactic to save your life or plant's life from the threats? What is the characteristic of animal?
effectiveness, like maybe aggressiveness.
Animal, animation, animated. What is any? Can move, right? So if some kind of threat factors approach you, because you are animal, you need to what? Move, right? If you don't move, you are not animal. You are plants. So what is plants tactic to save their life?
Can have poison.
Huh?
Having poison.
Having poison, yeah. But the important thing is they never ever move, right, against the threats. So at first time, they actually take the threats. Then, as he said, you should toxins or do something, right? So the plants need to be adjusted. When the toxin or when the threats approaching into plants, they need to adjust. If it fails, what happens? No survivor there actually, right? So that is very, very important. So as a animal, you human being need to move. So if this area is contaminated with mustard gas or chlorine, what you should do is, just move out. That is one good tactic as a environmental scientist and engineer. And then second, what you should do? Just find simple solution around you. Yes. So as she said, ventilation is very, very important. Ventilation. I'm just giving you $1 billion prize solution to you. If you get involved in the consulting field, and then you are working for the air contamination part, whenever your client drop by and ask you about how to repair the air quality of their building, of their facility, the best question is, as she said, ventilation. Yeah. You just cover the 70 or 80% of the air pollution problem. This is very, very important. I bet you, maybe 10 years later, when I met you, I will ask you if you are, engineering consultant. I will ask you. So my, solution is good enough for you for your, future work or nowadays work. I bet you. This really, means a lot actually. Ventilation is very, very important. All right. Okay, so how can we solve this problem? Well, using flux or using some kind of, velocity related, well, you guys can easily solve the problem here. All right. Just to skip this part. Okay. So far, we have dealt with some steady-state mass balance, which usually can say idealistic, boundary. But most of the environmental problem and most of the work you will deal as an environmental problem as non-steady state. It changes. The significant environmental factors can be changed with respect to time and with respect to concentration and with respect to very significant environmental properties. So here, what happens if the flow into a compartment is not equal to flow out So flow in and flow out, different. Well, we can assume one simple example. Flowing, there is very clear rate here. Yes. Well, first time, this fish is very happy. And, happy with SpongeBob and Patrick. Do you guys know Patrick and SpongeBob? Well, actually, I'm going to Doris will like the comic show, cartoon show. And they're always, I just forgot the fish's name actually, with Patrick. Patrick, I love Patrick actually. Anyway, first time, this fish is very happy with the environment. But, so it goes in the flow, in and flow out. But some stupid guy, that guy, just sinking this lake every night and using the tanker, he just dumped, a new containment flow. Right? So here, actually, right? But now this is totally different because there is one more flow validity here, right? So, but anyway, it takes some time for the flow out of the lake to increase the new higher concentration of protein. Because if this guy contaminate this pin rate every night, well, it will actually the maximum contaminant concentration approach at a certain time. Until then, the flow itself is very different. Flow in and flow out are different. So we can assume non-steady state mass balance here. So as you guys can think, the time takes to come up with this new concentration depends on actually residence time. As I already talked, at a certain point you can get the constant concentration actually. By the way, long residence time means it takes a long time for the protons to come to the new concentration, maximum concentration. So, actually, we can set up the new differential equation here. The mass divided by time. This is very small, a very short time equals F in minus F out. Here M is a stock or mass of protons or anything else in the lake, and T is time. And think about the F in and F out is all the same. In this case, dm over dt is 0, steady state, as you guys know. But when the flows are not equal, time actually indeed a very significant factor, as I've already talked, right? And we need to solve this differential equation, all right? As we already have talked, dm over dt equals F in F out, right? This is very simple differential equation, right? Which is related to time. So whenever you heard about some equation, with, whether it is algebra or whether it is differential, it is related to time. We call it mechanics. where do you easily find this word?
General physics work.
Except the lecture materials. If you have Rolex or Tech Heuer, or which one is much more higher? It's very nice. Such a hopeless to be rich. Anyway, if you have good, brand watch, you can find it on your, watch. Actually, can you see that on there? Because that is very watch. Anyway, kinetic means time. Kinetic means time. So when we talk about environmental kinetics or chemical kinetics, the change of environmental factors with respect to time. So kinetic is very, very important. As I already talked, as an environmental consultant, what you need to consider is the time and the money, right? So the concentration change of contaminants with respect to time is very, very important. So we are actually dealing with mass balance with this kind of physics. What is totally different, antonym of the kinetic? You are in kinetic. That means your heart is, kind of broken, and you don't buy your girlfriend, and you are actually, What is totally different, terms of kinetic? Dynamics, aesthetics.
Non-kinetic.
Just don't play with me. Tongue. Well, I think this is kind of very simple, freshman chemistry. You guys actually estimate, calculate constant. This constant. There is kinetic constant. And what is, except you? You are at the, at the state of this one. Everything changing. It is the end of something which related to thermodynamics. Heard about the equilibrium. Equilibrium is totally different. Equilibrium, everything actually ended. But you can see the dynamics in equilibrium. But compared to kinetics, equilibrium is the state everything ends. So if you are in equilibrium, you just like you have the mind of Buddha. Equilibrium. This is very, very important. How do you solve the problem in aspect of kinetic, of contaminants, or in aspect of equilibrium? Those can give you totally different solutions. Well, I think this is it for today. Well, we will talk about equilibrium and kinetics, and also mass balance, non-steady state mass balance more on Wednesday class. Any questions or comments? And one more thing, reading your text is very, very important. Also, my jokes are also important. You can find it in the exam. Why the silly jokes are important. Okay, thanks.